Hello guys, this is your cloud manager Gaurish with a new topic. Today we are going to deal with some problems related to Coulomb's law, and let's move on to the questions. Okay, the first question is the electrostatic force of repulsion between two positively charged ions carrying equal charges is 3.7 into 10 raised to minus 9 Newton when they are separated by a distance of 5 Armstrong. How many electrons are missing from each ion? So, from this question, we can understand that the question is to find the number of electrons missing from each ion or the charged particle. So, to find the number of electrons or number of particles, we have the equation Q equal to Ne from the topic of quantization. Q equal to Ne, right? Q equal to Ne, and from that we can find N or the number of particles, that is equal to Q upon E. So we need to find the charge of the particle or the positively charged ions, both having the same charge, right? And here the force is given, that is force is equal to 3.7 multiplied by 10 raised to minus 9 Newton, and we need to find what this is the charge. So here the distance is given r equal to 5 Armstrong. So we have the equation from Coulomb's law, or 5 Armstrong is equal to 5 multiplied by 10 raised to minus 10 meter. Okay, so the equation from Coulomb's law, that is F equal to 1 by 4 pi epsilon 0, or I can simply write it as K. F equal to K Q1 Q2, but here the both charges are same, so Q square divided by R square. So we need to find the Q, that is a charge here. So Q square will be equal to Q square will be equal to FR square divided by K, right? Yes. So applying the values given here, that is 3.7. F is 3.7 multiplied by 3.7 multiplied by 10 raised to minus 9, and that is the here the radius, that is the distance given as 5 multiplied by 10 raised to minus 10. Squaring that, we will get 25 multiplied by 10 raised to minus 20, and the whole divided by K. What is K? K is the value of K is 9 multiplied by 10 raised to 9 multiplied by 10 raised to 9. So doing the calculation, we will get the answer as 10 point Q square, that will be equal to 10.28 multiplied by 10 raised to minus 19 Coulomb. And so 10 raised to minus 38 Coulomb. Here we need to find not Q square, we have to find Q, that will be the root of 10.28 in 10 raised to minus 30, that comes out to be 3.2 multiplied by 10 raised to minus 19 Coulomb. So we got the Q for this equation. So now we can find the number of electrons missing, that is N equal to Q by E. Q is 3.2 multiplied by 10 raised to minus 19, the whole divided by the value of E, that is 1.6, that is elementary charge 1.6 into 10 raised to minus 19 Coulomb. So we will get answer as 2. N is equal to 2. So the number of electrons missing is 2. That is the answer, 2. So now moving to the next question, it is a free pith ball A of 8 gram carries a positive charge of 5 multiplied by 10 raised to minus 8 Coulomb. What must be the nature and magnitude of charge that could be given to a second pith ball B fixed 5 cm below the former ball so that the upper ball is stationary? The question is given as a pit ball A. A pit ball A is here. A pit ball A, and it is having a mass of 8 gram and carries a positive charge. Charge is given. Charge is given, and mass is also given. Mass is 8 gram. Is 8 gram, or it is in standard units 8 multiplied by 10 raised to minus 3 kilogram. Okay, and the charge of that pit ball Q1 is given. That is Q1 equal to 5 multiplied by 10 raised to minus 8 coulomb. Minus 8 coulomb. And also the distance between the pit balls is given, that is 5 centimeter. That is R equal to 5 centimeter. 5 centimeter, or otherwise it is 5 multiplied by 10 raised to minus 2 meter. And the question, the second pit ball B is placed below the former ball, that is A. It is placed below the former ball. B is placed below, and the distance between them is given as 5 centimeter. 5 centimeter. So the charge is given, that is positive charge here. This positive charge, and it is said that what must be the charge of the B, so that the upper ball A is stationary. That is, we know that this ball is having a mass, so it must have a weight m1g. M1 is given mass to A, so m1g is acting downwards. To stay in the stationary position, some force must act upwards. That force must be the repulsive force. Repulsive Coulomb's force must act upwards, so that the ball A is at stationary position. So the nature of the B must be same as that of the A. That is, the repulsion must be occurred. So that is the force. Which force? The repulsive force. That is, repulsive force must be balancing the weight. That is m1g. F is equal to m1g. So we can apply the equation here. That is K Q1 Q2 K Q1 Q2 by R square must be equal to m1g. Here we know the Q1, that is 5 multiplied by 10 raised to minus 2. So we need to find Q2. Q2, that is equal to Q2 is equal to m1g R square divided by K Q1. So applying the values here, that is m1 is 8 into 10 raised to minus 3. 8 into 10 raised to minus 3 into g, we can take it as 10 or 9.8 into R square, that is 25 multiplied by 10 raised to minus 4. 25 multiplied by 10 raised to minus 4 divided by 9 into 10 raised to 9, and Q1, that is 5 into 10 raised to minus 8. So by doing calculation, we will get Q2 as Q2 will be equal to 4.36 multiplied by 10 raised to minus 7 coulomb. And the nature is positive. So that was the answer to the question, and we are moving to the next question. A particle of mass m and carrying charge minus q1 is moving around a charge plus q2 along a circular path of radius r. Prove that the period of revolution of the charge minus q1 about plus q2 is given by t is equal to root of 16 pi cube epsilon 0 epsilon naught mr cube by q1 q2. This question is a good one. When it comes to the objective perspective, it will be this option will be given as the given as the options. Okay, when this question comes as an objective one, then this will be there in the options. So we need to find the which is the correct one from those options. So here it is to prove this equation is correct, and so We know that a particle is given that a particle of mass m and charging minus q1 charge. That is, the minus q1 charge is at the center, and another charge is revolving around that charge. That is, plus q2 charge is revolving around that charge in a circular path. And from that, we know that for this plus q2 charge to remain in that path, there must act an centripetal force. So that centripetal force must be given by the attractive force between q2 and q1. So that is, we can simply equate them. That is, F will be equal to F electrostatic. Electrostatic force must be equal to the centripetal force FC, centripetal force. F electrostatic force between them, that is q2 and q1, that is minus q1, that is attractive force, and that must equate with the centripetal force. So we can do it by 1 by 4 pi epsilon 0 q1 q2 divided by r square must be equal to the equation of centripetal force is mv square by r. From this, v square will be equal to 1 by 4 pi epsilon 0 q1 q2 multiplied by r divided by r square. So we will get q1 q2 by r, that is v will be equal to root of 1 by 4 pi epsilon 0 into q1 q2 by r. So I have got v here. What is the purpose of this v? We need to find period of revolution, that is t. We have the equation t equal to 2 pi r by v. So we can directly apply this value there. So that will be, that is t is equal to 2 pi r by v, that is 2 pi r by root of 1 by 4 pi epsilon 0 q1 q2 by r. Taking reciprocal, we will get 2 pi r multiplied by 4 pi epsilon 0 mr divided by q1 q2, and so the final answer comes out to be, that is giving this 2 pi r to the inverse of giving this 2 pi r into the root. So we get root of 16 pi cube epsilon 0 mr cube divided by q1 q2. So we have proved the answer. That's all. And moving to the next question. Two particles, each having a mass of 5 gram and charge 1.0 in 10 raised to minus 7 Coulomb, stay in limiting equilibrium on a table, on a horizontal table with a separation of 10 centimeter between them. The coefficient of friction between each particle and the table is the same. Find mu. So here there are two particles. It is on the table. Two particles are on this table and is having the charge mass 5 gram. That is, mass is given. Mass is m, and that is equal to 5 gram. 5 gram. Otherwise 5 into 10 raised to minus 3 kilogram. 10 raised to minus 3 kilogram. And the charge of the both of them have the same charge, that is q1 equal to q2. That is equal to 1.0 into 10 raised to minus 7. So here these two particles are on the table, a horizontal table. Here these two particles are the same, having the same charge or same sign, so they will probably repel each other. So in order to be in the equilibrium position, the frictional force between the particles and or the particle and the table must balance with the electrostatic force of repulsion between them. So we need to find both the frictional force and electrostatic repulsion between them, that is force of repulsion between them, and then equate it to find the mu. So we are getting into the topic, that is we can find the Coulomb's law by F is equal to 1 by or K Q1 Q2 divided by R square, that is equal to 9 multiplied by 10 raised to 9 into the charge is 1 point the same, so Q square, that is 1.0 or 1 into 10 raised to minus 7 the whole square divided by R, that is given 10 centimeter, so 10 square, that is 100 multiplied by 10 raised to minus 4, that will be 10 raised to minus 2, taking the minus 2, taking that 10 raised to 2 here and adding here, that is 10 raised to minus 2. So we will get the answer as something like 0.009 or 9 10 raised to minus 9 Newton. And now we need to find the frictional force, that is F friction, that is equal to equation for frictional force is mu mg, that is mu we don't know, and mu multiplied by mass is 5 multiplied by 10 raised to minus 3 and multiplied by g, we can take it as 9.8 or 10, and we will get here by doing calculation it will be 0.049 Newton, 9 mu Newton. So we can equate now, that is 0.049 mu equal to 0.009 Newton. Now we will get mu as 0.009 divided by 0.049, that will be 0.18. So the answer is 0.18. So next question, two insulated charged copper spheres A and B have their centers separated by a distance of 50 centimeter. What is the mutual force of attraction, force of electrostatic repulsion if the charge on each is 6.5 into 10 raised to minus 7 Coulomb, and the radii of A and B are negligible compared to the distance and of separation? Also compare this force with their mutual gravitational attraction if each weighs 0.5 kilograms. What is the force of repulsion if each sphere is charged double the above amount and the distance between them is half? And second one is the two spheres are placed in water, the electric constant of water is 1. So this is a combination of different concepts from physics, and now there is two insulated copper spheres, they are separated by 50 centimeter, and also the charge is given, that is 6 point, Q will be equal to Q1 is equal to Q2, that is equal to 6.5 into 10 raised to minus 7 Coulomb. Okay, and the distance between them is also given, that is R equal to 50 centimeter, that is equal to 4 or 50 multiplied by 10 raised to minus 2 meter. Okay, now the question is here to find the Coulomb's force, that is F in the air. So F air will be equal to K Q1 Q2 divided by R square, and that will be 9 into 10 raised to 9, that is the value of k, 9 into 10 raised to 9, and multiplied by the q1 and q2 are same, that is 6.5 into 10 raised to minus 7 into 6.5, or the whole square. Okay, whole square divided by here we can write it as 0.50 the whole square. Okay, 0.50 the whole square. Now doing calculation, we will get the answer as 1.5 multiplied by 10 raised to minus 2 Newton. And now we are asked to find or compare this force with the mutual gravitational force of attraction also. So we can find the gravitational force of attraction by using the equation Fg, gravitational force, that is equal to Gm1m2 divided by r square, that will be equal to G is 6.67 into 10 raised to minus 11, that is a universal gravitational constant, and that multiplied by the mass of the sphere is given as 0.50 kilograms. So we can directly apply 0.5 into 0.5 divided by r square. R will be the same here, that is 0.50 the whole square, or 0.5 square, and by doing calculation we will get it as, they will be cancelled out, and the answer will be 6.67 multiplied by 10 raised to minus 11. So here by comparing, we know that the gravitational force is very less than electrostatic force. This is of the power 10 raised to minus 11, while the electrostatic force is of the power minus 2. There is a huge difference between these two forces. And now the other question is to find the force of repulsion in two conditions. The first condition is each sphere is charged double the above amount, double. So we can find it now. We can write it as f dash share. Okay, f dash share will be equal to k double, that is q1 multiplied by 2q2 divided by and the question is the double and the distance between them is half, that is r by 2. We can write r by 2 the whole square, the whole square. So that comes out to be 16 times the first force, that is the FIR. That is 16 multiplied by k into q1 q2 divided by r square. This 16f, simply 16f, and we have got the value of f here, that is 16 multiplied by 1.5 into 10 raised to minus 2 into 1.5 into 10 raised to minus 2, and that will be equal to 0.24 Newton. So that's over. And next question, it is the next condition is two spheres are placed in water. It is placed in water. So what will happen? The Coulomb's force will be, when it is in water, will be equal to 1 by 4 pi epsilon 0 k or epsilon 0 r. K is the dielectric constant of that medium, and here the dielectric constant of water is given into q1 q2 by r square. Simply we can write it as f air by k. Here k is given as k is equal to 80 in the question itself, so we can give the values 1.5 into 10 raised to minus 2 divided by 80. So the answer will be 1.875 into 10 raised to minus 4 Newton. We can approximate it as approximately it can be written as 1.9 into 10 raised to minus 4 Newton. So that was the answer, and we can see the other questions in the next part of the video. And to know more about the cloud vendor, visit our website. You can Google by typing cloud vendor Gaurish. Site appears as the first result, and or simply search cloud vendor and you will get the site as the third result. And also you can follow us on different social media platforms, and you can follow us on Instagram, and you can follow on WhatsApp. I have created a WhatsApp group for discussions on different doubts you have, and the links are given in the description box. Also a Telegram group for discussion and the same purpose, and a channel is also formed for giving off your learning steps, and all the links are given in the description box. You can check it later. You can also ask your doubts as comments in YouTube, and if you want more videos which would be uploaded in the coming days, please subscribe our channel and press that bell icon for getting notifications on time.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.